my name is Arezi Zawdiuki, and this is my Lab 3 on the black hole. So the purpose of Lab 3 was to use Newton's second law, given the position values of a star, to find the net force on the star. You were also supposed to use the computed values that you got from entering your information into VPython, and Newton's law of universal gravitation to find the mass of the black hole. And the formulas for both Newton's second law and Newton's law of universal gravitation are to the right. So what do we know? We know that the system is the star. The mass of the star, the position of the star, the position of the black hole, and the time step were given. And then we were to assume that F net is equal to the gravitational force of the black hole on the star. So in order to better understand this problem, I went ahead and quickly sketched out a free body diagram, kind of explaining the motion that we are observing. The calculations that I did in VPython were as follows. I changed the appropriate lines of code to account for the momentum formulas, velocity formulas, as well as dp dt and F net, according to Newton's second law. I then went in to calculate the mass of the black hole using the gravitational formula rearranged so that the mass of the black hole is equal to F net times the magnitude of r squared over g times the mass of the star. R being the distance between the initial position of the star and the black hole from center point to center point. Initially, I tried to calculate this by hand, but I found that calculating in VPython was much easier. So I set the initial conditions G and BH pause being the position of the black hole, in the code, and then I changed the print line to the following. And then after I ran the code, I received the following values. F net is equal to 1.026 E27 newtons, and the correct value for the mass of the black hole, which is 3.5801 E to the 31 kilograms. The formulas, or the values in yellow, are again what we were given in the problem. So what does all of this mean? I did an analysis on all of the data based on the questions that were posted on WebAssign. So the net force, the parallel net force, and the perpendicular force are different from dp dt net, dp dt parallel, and dp dt perpendicular, even though Newton's second law states that the values are the same. So when you're talking about dp dt net, dp dt parallel, and dp dt perpendicular, you're looking at the rate of change of momentum along those respective axes. And when you're talking about the net force, the parallel force, and the perpendicular force, you're looking at the gravitational attraction of the star to the black hole along those respective axes in this problem. If you're talking about F net, F parallel, and F perpendicular, you're looking at whatever force that represents. And in this case, that force was gravitational attraction. So then the question comes, if the black hole were switched out with a different black hole, would we be able to tell? The answer to that is no, because we have to look at the effect on the star. So according to the guidelines or stipulations set across in the what if question, nothing changed except for the black hole. The position of the black hole remained the same, the position of the star remained the same, meaning that the position values for the star remained the same. So that would produce the same values that led us to compute F net. Since we set F net equal to the force of gravity by the star on the black hole, or I'm sorry, by the black hole on the star, this is the only acting force on the star, and therefore the values wouldn't differ. So if you ran it through the same computation, you would get the same result for the mass of the black hole. That concludes my Lab 3.